After our raw photos have been processed and turned into sRGB 8-bit TIFFs, it's time for us to jump in reality capture. Here at the top I'm gonna choose the 1+1+1 layout. The first tab is gonna be the 1DS, the information about the photos. This is the 2D tab, the photos themselves. This is gonna be the 3D tab with the grid, 3D models, points, so on and so forth. We can import our source photos from this menu or just drag and drop them like I would do. Nothing could beat the good old drag and drop if you ask me. So here goes the first folder with 162 images, and then the second one. I'm using the sRGB images that we have converted from our raw images because reality capture can understand the raw files, but the conversion to 8-bit is pretty unpredictable. It's much better to do it by hand. So we got all the facade materials and corner source photos in there as well. And let's check the metadata. The resolution, as you can see, is 3K by 2K. If you have downloaded the project files, you can choose the resolution that is appropriate for your computer. Now let's visit the alignment settings really quickly and set the image downscale factor to 2. It could be slightly counterintuitive that higher values create lower resolution results. Think of this number as a multiple by which the application reduces the resolution of the source photos. 2 times smaller than the original, 3 times smaller, so on and so forth. We don't need to downscale the image too much in reality capture because we have already downscaled it in Darktable though. The detector sensitivity, I would keep it at its default setting, which is medium, and everything else as well at their default settings. Now let's just align the images and see how it goes. Usually, if the model is assembling pretty neatly at this stage, you can be sure that the mesh will be alright as well. The points are looking great, I think. I will switch over to the layout with just one window, except the 1DS, and it will be our 3D window. So we have 310 images that are all aligned. That is very lucky. What we can do now is export the registration, or the component in other words. I'm creating a special folder for that. I'm gonna call this component facade_01. This registration or component stores the position and alignment of all cameras as calculated by reality capture's matching algorithm. It opens up some interesting possibilities, for example, the so-called component workflow, which we can try right now. Essentially, this workflow is based on calculating the chunks or components separately, then merging them. And since our first chunk or component was exported out, we can create a new reality capture file and keep going. In this fresh file, I'll drag and drop all the photos that relate to the second component, the wall. Here they go. So first we calculated the facade and the corner, this chunk of the model. Then we will create the wall separately. I hope it makes sense. And if everything works, then we can just merge them from within the reality capture interface. So let's align the next pack of images. And here we got our wall. Nearly all images have been aligned, which is great. And you can see that this pack also has a little bit of overlap with the previous one, and that is important. Otherwise, the two packs won't merge simply. So after exporting this registration, we can go to a fresh file once again and go over to the workflow tab and find a component button. Navigate to the folder with the components, select everything and import them inside the reality capture. These components should be marked with this star icon. And if we want the wall chunk to snap to the first component, to kind of get aligned to the first one, we can go and select all cameras of the first component, which is the facade, either with the camera lasso or from the 1DS menu. And down inside the settings, we need to find the prior pose menu. And in the absolute pose, we need to check the locked, meaning that we lock the absolute position of that piece. So the second one will have to snap to it. Now down into the alignment tab, let's press the Merge Components button. It shouldn't take awfully long. And indeed, I have an impression that these two components have been aligned perfectly. All cameras have been aligned. Very nice. I'm gonna call this component Facade plus Wall. And if we compare the point count, we can see that the first one is nearly 350,000 something. The second one was around 500,000. And the third one naturally is around 700,000, a sum of the previous two components. So that's how the components can be calculated separately in reality capture, then merged down further down the road. Sometimes it's way more efficient and even faster than calculating everything in one go. It is especially worth doing it like that if you have the footage filmed on different devices, for example on DSLR, on drone, and on, I don't know, GoPro. Then it makes sense to use the component-based workflow. Or if you have different chunks of building, different modules that you want to be working on separately. Especially when at first you try to throw everything at reality capture, all inputs at once, and you see that the resulting model looks like it's made by Doctor Strange or something like that, then it's totally worth experimenting with the component-based workflow and calculate it chunk by chunk. Now, while we are still in the point cloud zone, it would be appropriate to tweak a few things related to, well, points. For example, the scaling of the points and the ground plane. But first let's start with importing just the facade component inside a fresh reality capture file. We will be working with this chunk throughout the tutorial, and then we will probably import the wall as a separate one. So I created an extra window for the photos. Now let's head over to the Tools menu and select Define Distance. We need to find a straight line, preferably the one that we know the rough measurements of. For example, this line that connects two sides of the door, I know that it's approximately 1 meter wide. We can disable the camera's visibility so they don't block the view. So here we have our line consisting of 2 points, and we can see our 2 points in there, each corresponding to a bunch of photos. What we need to do is click on every photo, but first let's uncheck the Define Distance command, otherwise it won't work. So on each photo we have to place the marker, and I'm placing it at the corner of the door because that's the easiest part to eyeball. And then I'm pressing the down arrow while still holding the mouse button. And when you do it a few times, reality capture will help you to place these markers automatically. That's pretty close to how the 3D tracker works in Blender and in other software. So you should be familiar with it, I think. And I'm gonna do the same for the second point. First, click on it, place it in some high contrast area that you can easily find, then press down arrow a few times consecutively until reality capture helps you to place all the markers. So now we just have to go down to the distance menu, and in the define distance field type in whatever we have there, 1 meter for example, and we see an error. That's not a showstopper, we just need to update the configuration of the alignment. So back to the alignment tab, hit update. Boom, now it should read correctly as 1 meter. So that's approximately how we define the scaling of the 3D scene from within reality capture. One more thing that is worth defining at that stage is the ground plane, the general orientation of our 3D scene, in other words. First, we no longer need to see the photos, so I'm just leaving the 3D viewport in there. It would be cool if we could orient our model to grid. In the Tools menu, we have the ground plane command. Let's press it, and then we will see the gizmo that we can use to reorient the model. I find it slightly easier to do that in the orthographic projections. So in the View menu, I'm switching over to the top one and rotating it into place like this. Then the next orthographic projection, which is left. Because this shack has become pretty crooked over the years, it's not an easy task to orient it properly to the grid. But anyways, and that is pretty much it for the alignment part. let's go back to the perspective mode to see what we have done. It looks to me that we have aligned it pretty well. We couldn't ask for more. It sits pretty squarely on the grid. I think that will do.